Lesson 2.8 is called Rationalizing Monomial Denominators. Monomial means single term. Think mono-y mono. We're going to go one-on-one. Okay, single term. So you see in all these problems, there's just one term in the bottom. Problem is you can never, ever, ever have a radical in the denominator. Never, ever, ever, ever. So never have a radical in the denominator. So you do what's called rationalizing it. What you do to rationalize it, you're going to multiply this fraction times the radical that's on the bottom. So I'm going to have square root of 10 over square root of 10. What would this make? Wouldn't that be 1? Anything divided by itself is 1. So I'm not actually changing the value of this problem when I multiply by 1. Just like if I had 10 times 1, that'd stay 10. But I'm going to change how it looks. Then we know we multiply straight across. That's 2 square roots of 10 over, that's the square root of 10 times 10, which is really the square root of 100, which is really 10. So remember we talked about anytime you have a square root of a number times itself, that's really going to cancel and just be the number again. Then our job is to just simplify. Can't simplify the square root of 10, it has no perfect square, but I can do the 2/10, make it 1/5. So I don't really need the 1 on top anymore. It'll be square root of 10 over 5. Same value, I can show you. If I were to take 2 divided by a square root of 10, that's what I get. If I were to take a square root of 10 divided by 5, same value. Just made it to where it didn't have a radical, excuse me, in the denominator. All right, next one. We'll multiply by this denominator, square root of 54. Multiply straight across, I'm running out of room here. That'd be 3 square roots of 54 over whatever 54 times 54 is, and then square root that again is back to 54. Now my question is, can square root of 54 be simplified? Let's think about that. What is 54? Would it divide by 4? No. Shouldn't be... Oh yeah, it is 9. 9 and 6. Duh. 9 and 6. So I need to actually simplify that into a square root of 9 and a square root of 6, which is a 3 square roots of 6. 3 times the 3 in front is a 9 square roots of 6 over 54. And then I need to simplify these. So 54 divides by 9, we said 6. Well, this would be taking out a 9. That would be a 1 over 6. So square root of 6 over 6. Right, number 3 has a variable. Doesn't matter. We still want to get rid of that radical in the denominator. So multiply by that radical, top and bottom. Multiply straight across. You get 5 times the square root of 9x to the 7th over. So think about this would be 81. Square root of 81 is back to 9. That would be 7 times 7, or actually 7 plus 7 with our exponent rules is 14, but divided by the index is 2 would be back to 7. So it's just itself. Right, then let's simplify this. That would become, square root of 9 is a 3. X to the 7th would need to become x to the 6th with a leftover square root of x. So 6 divided by 2 would be x cubed. Square root of x over 9x to the 7th. That would be 15. X cubed. Square root of x over 9x to the 7th. Divide out a 3. That would be a 5 thirds. This would be 7 minus 3 is 4. X's would be on the bottom. Square root of x on top. And then last one, multiply by the square root of 10 n to the 5th. On the bottom, it's just going to be 10n to the 5th. 10 cannot be broken down, but I can take out an n to the 4th, would be n squared. That would be 4n cubed. 4 tenths would simplify down to 2 fifths. 5 minus 3 would be 2, would be on the bottom. Square root of 10n on the top.